Good morning, students, and any parents who happen to be listening to this as well. This is Mr. Giomini. Just kind of giving you a little heads up if you get onto the blog early this morning, or just a little review if you get onto it later this afternoon after school, about line plot. We talked about this in class today. A line plot is a nice way to organize numbers. It's not a great way to really analyze numbers per se. It's just a nice way to kind of organize things. They're I find them to be generic, but if we take a look, I'm going to call this home runs in a career. Let's see here. My pen, should be writing. Try this one here. Sorry about that. There we go. Home runs, I'll abbreviate that HR. Home runs in a career. And we'll just to say this is one person's career. The numbers aren't arranged in any kind of order. 17, 25, 18, 19, 20, 16, 14, 18, 19, 18, 8. My lowest number is 8. My highest number is 25. Now I need to arrange numbers from 8 to 25 on this line. Now I tend to go by, I won't go necessarily by ones, I may go by twos, so on those nature. So let's see here, if I could go also by threes, fours, fives, but I'm going to go by twos. So I'll go 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'm going to continue it on just to fit the whole line. I don't necessarily like to stop here and have this line with all this length left. So I'll go 26, 28, 30, and we'll just stretch the 32 right here. Okay, now all I do is I go along, and it's called the line plot. Here's my line. Now we just have to figure out what are plots. And plots are those little X's that you put where the number would fall on the line. So a 17, obviously there is no 17, but it's between 16 and 18. So I'll put a 17 there. I'll put an X there. I'll cross it out so I do not use it again. 25, that'll come in between 24 and 26. I'll cross it out so I don't use it again. 18, which is right above the 18. And notice how I'm trying to keep those X's, those first plots, along the same kind of line there, along the same plane. 19, 20, 16, 14. I have another 18. I just put that plot right above the first plot I had for 18. 19, same thing, right above the first 19 I had. Another 18. And finally an 8. Now, we talked today about measures, or we will talk about today, depending on what time you watch this video, measures of central tendency. You used to call these landmarks. We do not use that terminology anymore. This is the more appropriate terminology. And we talk about measure of spread. Measures of central tendency are the mean, mode, and median. These should be familiar from last year. And then measure of spread is what we call the range. Remember the mean? You add up all the digits and divide by how many numbers, or add up all the numbers and divide by how many numbers you added up together, the total sum of numbers you added up together. Mode is that number that appears most often in the set of data, and the median is that number that appears in the middle from least to greatest. And then range is the difference between the maximum number in the set of data and the minimum number in the set of data. So I'm not going to calculate the mean for you. I want you to do that. The mode I can tell very easily is 18. There are 3 plots above the 18. No other number has appeared more than that in this set of data. So my mode is 18. Now to figure out median on a line plot, you can do multiple ways. You could cross out going back to front, but I kind of like just to organize numbers from least to greatest. So I know there's an 8, there's a 14, there's a 16, there's a 17. There are 3 18s. I must put all 3 18s down. Let me slide this over. There's 2 19s, a 20, and finally a 25. Okay, let's see here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So cross out front to back. I will see that my median is also 18. Now remember, my range is the measure of spread. The range is the difference between the maximum value and the minimum value. So I just go 25 minus 18 will give me the range. That gives me 17. Again, I will let you calculate the mean. We'll probably use more of the term average this year in class. But here's my question, and we just need to start making inferences, especially about this graphing and data, graphical representations of things. If you had to make an inference, what would you infer would be, out of all these numbers, when do you think would have been the end of this baseball player's career? And explain why. So which of these numbers here, 17, 25, 18, 19, 20, 16, 14, 18, 19, 18, 8, if you had to make an inference, an educated guess, which one of these numbers would represent the number of home runs he hit in his final career, or in the final year of his career? And then give me a reason why you feel that way. So, and if he was ever an all-star, in what year do you think or how many home runs do you think he would have had that all-star year? Give me an inference on that and an explanation. You can post it to the blog if you like. All right, take care. Bye.